Okay, I'm going to talk about addressing modes and their use in um, assembly language low-level programming. Addressing modes are an important thing to get your head around, and depending on what you want your instruction to carry out, will dictate what addressing mode you use. I'm just going to talk briefly about each one and where they might be used. Okay, so for example, let's go through the four addressing modes we have available to us are immediate addressing, direct addressing, indirect addressing, and indexed addressing. And I'm just going to go through each one by one, explaining what they are. Immediate addressing is fairly straightforward. It's where the actual value that you want to copy into the accumulator or into the register that you want to move data into is the operand um, of that instruction. So you've got an instruction, let's say load instruction, and then the actual number you wish to load into the accumulator is the operand, and so that is immediate addressing, where you include the actual value as part of the instruction. Direct addressing is where the operand is the address location of the data you wish to copy into the accumulator. Okay, and likewise with both with direct addressing, if you want to for storage, for example, it would work the same way. You would store the data immediately in the address that's included in the instruction. Now, indirect addressing is quite an interesting one in that the address that's contained within the instruction as the operand contains another address. So you're pointing to a location that contains an address to the data that you wish to point to. Now, you may wonder, well, what's the point in that? It seems like a too unnecessary, an unnecessary step. Well, indirect addressing is particularly useful if the memory address, for example, is likely to change during the execution of the program. So if you need within your program to access different pieces of data at different iterations, it will allow that value to be changed in the in that memory location, whereas you can't change the value in the instruction itself. The operand remains the same. So by using indirect addressing, the address that you're pointing to that can change. Okay, so you've got the address included in the instruction, the operand points to a memory location that contains an address. That address can change. And so you can actually point to different memory locations that will be accessed by the same instruction. Another example would be, for example, pointer values. If you wanted a pointer, you wanted to set it as a pointer value. As the pointer changes during the execution of a program, you might wish to point to use the pointer to point to different values or different memory locations during the execution of the program. And again, so you would use indirect addressing for this, because the actual location you wish to point to might change, even though you don't want to change the instruction that you're executing. Finally, there's indexed addressing. Now, indexed addressing is where you have a value stored in a register called the index, unsurprisingly, and then you would have an instruction that points to an address. But in actual fact, when you use indexed addressing, you increment that address value by the value in the register. Now, this can be useful if you want to access memory locations that are contiguous that you want to increment. So you want to go from 1000 to 1001, then in another iteration of a loop we'll go to 1002. Instead of you can't change the address in the instruction, but what you can do is increment the register value, the index register. And so by using indexed addressing, if you had in the address in the indexed addressing in the instruction using index addressing. Let's say that 1000 and the index register contained 1, then that would go to 1001. You increment the index register. The next time you get to that instruction, even though the address in the instruction is still 1000, the value in the register is incremented is now 2. And so you would be accessing data in memory location 1002. And so that can be used, again, within a looping construct to access different pieces of data that are stored in memory, slightly in different memory locations, using indexed addressing. So those are the four main addressing modes that you need to be familiar with. I hope that has helped. I hope that's helped clarify that, and it all makes sense.